Hello everyone. Welcome to the C++ Bootcamp. Today we're gonna do something we had done before, which is implement a solution to a problem using C++. And we're going to be constrained by the things that you've already learned, so that I don't try to get too fancy. But if I end up having to do something that is outside of what we've already talked about, I do my best to try to explain it as I work with it, but then we're going to have future sessions that probably dive deeper into some of these things anyway. So don't worry too much. Just hopefully, take it easy, and we'll see if we can't get through it without any confusion. I can't promise that, but I'll do my best. So the problem that we're going to solve is one that deals with the following what situation? Yeah, okay, situation, right? So we've got a character array, and the character array is composed of only letters. So, Mary had a little lamb, for example. Now what we want to be able to do is take this character array and count the number of times each one of the letters has appeared, and also at the end print a little summary that shows the count for each letter, and also present the letter that showed up the most. So in this example, we have M-A-R, so M-A-R-Y-H-D-L-T-I-E, and B. And we also have upper and lowercase. So if we had to go through this manually, we would do something like M, A, H. So as we encounter the letter, right? So M-A-R-Y, and we're not thinking about spaces. So H. So M has shown up once, A has shown up once, R has shown up once, Y has shown up once. H has also shown up one time. Now, little a has shown up already, so now we have 2. D has not shown up, but now it has, so D has 1. L has not shown up before, so now L has 1. I has not shown up before, so I has 1. T has not shown up before, so now T has 1. T has shown up before, so now T has 2. L has shown up, but as capital L, not little l. So little l has only shown up once. E has not shown up before, so little e has 1. So now capital L has shown up, so now that 1 becomes 2. A has also shown up, so now that A becomes 3. Little m has not shown up, so little m has a count of 1. And B has not shown up before, so B has a count of 1. So we've gone through the string, and we've counted all the occurrences, and at the end we would print something like what I've just displayed here, and also say letter, well, something like letter that showed up the most. And it would be the letter little a with a count of 3. And we could also say first occurrence. So here's another thing. If we wanted to say for all the characters that had a count of greater than 1, when was the first time that we saw that character? And the first time would be the index in the character array. So if you remember what I've said before about character arrays, the index is 0, and then it goes up by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm going to print 0 again, but this means 10. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And the last the last position after 19 would of course have a null byte. And this would be your character string. So the first time that M showed up, even though it showed up once, so it showed up one time and it didn't show up anymore. Little a has shown up 3 times, and the first time that it showed up was at index 1. Big L has shown up more than once, and the first time it showed up was at index 9. Little t has shown up, and the first time that it appeared was at index 11. Let's see, and then that should be it. So after we've printed the letter that shows up the most and its count, we could also say, so let's see, we could say frequency occurrences, well, letter frequencies. We could print this out, and then we could print out a divider, just to have something to divide the title from the entries. And then we could say, after we did the letter that showed up the most, we could say occurrence. Maybe no, I don't know. Let's see. So letter frequencies and then maybe letter occurrences. Might not be the best thing to call, to use for this, but okay, so we'll say letter occurrences, and then we will do, for the letters that showed up more than once, we'll print them out and print that index. So it would only be every character in the character array that showed up more than one time. So these would be the only ones. So remember, this is the count and then the index where it first appeared. The count and then the index where it first appeared. The count and then the index where it first appeared. So we've got a general idea of what it is that we want to do. So now let's talk about how we're going to go about doing it. So for right now, we can use our test string, actually. We use our test string as the character array. Now, let's see. So if I said character pointer, our string, and then put Mary had a little lamb, gotta do that because const char star cannot be used to initialize an entity of char star. Okay, so const char star. Now, what the compiler just said, let me go back. So looking at char star, this would be a pointer to a character. But because I'm using a string that won't change, I can't just say character pointer out string. I have to say const char star. And character star, if you remember what we were talking about in one of our previous sessions, this pointer is really going to point to a block of memory, and that block of memory has a size for each element that is exactly 1 byte. So when we run the program, this will be clear. This will become more clear because what we'll see in memory is we have a location in memory that has a beginning address, and that beginning address will have a value of M. And then if you keep looking through memory, you will see in hexadecimal our ASCII characters. So if we open up the browser here and look back at the ASCII chart that I like to reference. Let's see, CMU ASCII, there we go. Blow this up a bit so we can see it. So what you're going to see in memory will be these the hexadecimal versions of these characters. the actual numbers, and then the value will be we will just know what the value is based on the numeric representation that's in that location in memory. So first, let's do that so that you can see what I mean, because I don't want you to think that it's not magic. It's just with C++ and C, you can define these blocks of memory that look like this. I'm not going to change this string. I'm going to use the string to come up with a way to print the letter frequencies and then to print the letter occurrences. So if we start our debugger, first thing we're going to do is just verify what I said about this pointer. So outString has a location in memory, but it's not initialized yet. So once I step over this line, now outString has a value in memory and then the actual string. So if we look at this location, and this number is a memory location. Memory locations are, I mean, they're just like a mailbox, but it's mailboxes for the computer to store things in and get things from. So if we just go up here to this memory view in the debugger, and we copy, well, actually, we paste our memory address over to the side, you see something that's printable so that you can read it. But then you also notice that you've got your characters in here. So each byte is a character, and a byte is 8 bits. And we will get into this. We'll get into this in future videos. So right now, all I want to illustrate is that when I said const star out string, I made a variable. That variable has a memory location, and that memory location is where our string is held. Now, the memory locations are going to be accessed using a for loop, and we've done that before, so we're going to do that again. But in order to keep up with our letter frequencies, what I want to do is I'm going to create an array, and I'm going to use that array to, for each location, hold the count for that letter. So the first thing I'm going to do is tackle the letter frequencies. The next thing I'm going to do is figure out how to associate the letter occurrences with the letter frequencies. And remember, the occurrences, we only care about the occurrences where the number of times that letter has shown up in the character array is greater than 1. So now that we have our string, let's talk about our array. So we need 2 arrays. We need a frequency array, and we need an occurrence array. If I can spell it, if I can spell it correctly. Okay, occurrence array. And I say array, but I'm writing container because, I mean, it's a container. It's going to contain things. That's just how I think about it. But it's going to be an array. And the way that we define the array is, of course, with our brackets. And we're going to then initialize that array with our initializer. So every location is set to 0. But the first question that you might have, and if you don't worry about it, you'll think about it and then say, hey, wait a minute. In the brackets, we're supposed to say how big we need this array to be, but I haven't done that yet. Now, what I'm going to do is, because I care about all of the letters, and all of the letters can be uppercase or lowercase. Let's see. Okay, so what I need to do is, let me think about how to best represent this. I want to have A to Z be represented, excuse me, and then I want, and then I want little a to Z to be represented. So let's think about that. From a value of 90 to 65. So from the value of 65 decimal to a value of 90 decimal would give me integer values, decimals that I can use to do do what's called a hash. So I can create a hash that I then use as an index into the array. But that array needs to have enough positions in it so that I can keep track of capital A through capital Z and lowercase a through lowercase c. So I'm going to use the numbers to do that. So the distance between from 90 to 65 is 25, I believe. So 25 plus 1 gives me 26, and that makes sense because there are 26 letters of the alphabet. But 26 letters of the alphabet, let's see, 26 letters of the alphabet times 2 would give me all of the locations I would need for capital A through capital Z, lowercase a through lowercase z. So I need those 52 locations, and it's going to go from 0 up to 51. And that's because, remember, we're talking about an index into an array in C++. So what that means is we're going to say 52 and 52. So that's the first part. We're going to create a frequency container that will hold array locations where we can +1 when we see things. But that doesn't help us. So that's the storage. But the next thing is how do we create this thing I just said, where basically I'm going to convert an A into the representation. So 65. Now that's easy enough because I can just say the int of A with a cast, if you remember that we said that. So in int, casting that back to an integer is going to give me the value of 65, right? Because 65 is A and A is 65. Okay, so we've got 65. Now I need to take this 65 and I'm going to mod it against what I'm going to do here. So what I need to do is I need to force this 65 to always be location 0 in our index in both cases. Because remember, what we're trying to do is we have 26 locations for capital A through capital Z, and then 26 locations for lowercase a through lowercase z. So if I mod by 65, that won't really, it'll only work if I've got, actually, let's see, would that work? No, because if I take a modulus, I'm going to use a modulus, right? That's the first thing. What is a modulus? So the modulus in a mathematical operation is going to look like some number, % is modulus in C++ and C, some other number. So the remainder is what the modulus is. So 10 mod 5 is 0 because there's no remainder. 11 mod 5 is 1 because there's, 5 times 2 is 10 plus 1 is 11. So that's the modulus. That's how that works. Now what I'm saying is if I take the integer of capital A and modulus at 65, I'm going to get 0. And that's what I would expect. And that will work for every number that's not an uppercase number. Oh, actually, you know what I think I can do? What I can do is I can say, this will work just fine for A through Z. So what I'm thinking of, and I will do it right now, is for unsigned int, I is equal to 0. I is less than, the Mary Had a Little Lamb has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 characters, I believe. All right, and then the way I can check that is right now. I will do a quick check, and then we'll do the loop because we're going to use for loop for this. But I want to make sure that what I'm saying is not completely dumb. so outstring 19 should give me the lowercase b, and if that's true, then we know that we've got 19 characters. And that's important because the next thing I need to do is create the for loop that I'm going to use to go through the character array. So let's do that. All right, so initialize the array, print some value, and I hope I didn't print junk. Okay, yeah, little b. So good, we're good. We are just fine. Okay, so now I know I can say some for loop, do stuff on the inside. So I can say unsigned int I is 0, while I is less than 19, I plus plus. Now, I'm only gonna make this work with this string just because I want to be able to get the implementation completed and we print out everything we want to print out. But truthfully, there are other functions you can use to get the value of character arrays, and we'll get into that. It's just right now, I don't want to add more things than I need to just to get the point across about how to solve this solution with what we have right now. So we don't have to do any more than we need to. So for const char star outstring character array, we're going to do the loop, and in the loop, we're going to say, let's see, unsigned int char index equals the cast of outstring at the location I. So outstring I cast to an integer should give me mod 65. We said should give me some index. And actually what I can do is say, I don't know what it is right now. So I'll set it to, actually I need this to be something else, not unsigned. And the reason that I don't want it to be unsigned is because I don't want to start at 0 by mistake and then end up adding 1 to the location for a capital A in the array that I've in the frequency container or in the occurrence container. So now let's see, I want this to be set to -1 so that I can catch invalid conversions. So the next thing I'm going to do is I'm going to say char index. Well, wait, I don't want to do that yet either. So char index is -1. I'm going to say if the letter I'm dealing with is even something I should consider. So the only thing I care about is that okay, so what I can do here is I can say, well, I don't want to make this I don't want to be too clever. Let me go ahead and just do it explicitly. So if int outstring at index is greater than equal to and less than equal to, and we've done this before. So outstring at location is less than equal to, what is that? Where's my, go back here. So 65 and 90. So less than equal to 90, what do we want to do? So in this case, we know we've got something that is in between the capitals. Need another one? Oh. One of those goes there. Okay. If I'm dealing with an uppercase character, then I know I can just do the char index is equal to the actual value mod 65, because remember what this is going to do, this gives us an index starting at 0 in either container. All right, so if it's not that, then we say if we're going to do an else if. So else if outstring is, so if we're not talking about something uppercase, if we're talking about something lowercase, then it's going to be from 97 to 122. Looking on this side of the actual ASCII thing. So 97 through 122. Oh, I'm sorry. So wait, yeah, it is 97. What was I thinking about? 67. Yeah, 97, 192. I mean 122. Let me look again. All right, 122. Right. So if we're talking about something lowercase, then it should be an index in between, well, after, what is that, 26. So now it's going to be, so char index outstring mod 65. So if we take something that is outside of the bounds, like so 97 mod 65, I wonder if I have Python here. Okay. So 97 mod 65 is 32. So in order to fix it so that it's at 27, I think I just need to say 32 minus 5. So actually, that might not be right. Minus, so 97 mod 65 gives me 32, but then the problem is it shouldn't be 32. So 0 through 26 will be here. 27 should be the, oh, okay, well, maybe that does work. So 0 through 26, well, wait, it should be 0 through 25, so it should be 26. So minus 6. Okay, so what I'm trying to do right now is, because I've got an array that has 52 locations in it, I want to make sure that when I have a lowercase letter, that I'm able to put the +1 in the right place. So I think taking the modulus and then subtracting 6 will get me to where I need to be. So now we're going to find out if that's right. So taking the modulus and then subtracting 6 should get us there. Okay, and then let's see. So we've either got an index that's, all right, so you know how we can test this? I know how we can test this. Okay, so let me set a breakpoint here. I have an index. That index should lead me to the frequency container. So the first thing we're going to do is let's see if we can print out these letter frequencies. That's the first thing, right? And okay, so if this works, then what we should see is our first column of numbers here working like we need for them to work. And it won't, well, actually, we could make it be in order, I guess. That should work, but then that would require, okay, so what I'm thinking about now is we've got two parts to this, the main piece of this. So we need to be able to go through the string and figure out the frequencies, and then we need to be able to print out the frequency. So if this works, then we should have all the frequencies we need, but they're not going to be in the order that we need for them to be in just yet. So in order for them to be in the right order, we need to be able to take this string and actually show the frequencies. And we can do that. So let's try it. Let's see what that would look like here. And then, if we get this to work, then maybe we'll go ahead and just take a break, and then we'll come back and we'll do the second part. Yeah, that I think we'll do that. That might make more sense instead of it taking longer than it needs to. So let's see. We've got, let's print this out. So in this for loop, we're going to calculate the frequencies. And then after that, we're going to print out the frequencies. So we would just say cout. And we'll print it just like it looks. Okay, so then we'll say, excuse me, we will go through the string again. And we'll have to use this, we will have to use the same kind of conversion to make sure that we get the right location. Because we're going to make it look like what we have above. And this will make sense once I actually run it. Because I'm kind of talking out loud while I'm doing it. So I know it's like, what do you mean? But okay, so here, here, here. All right, so we've done this part for the index, and then we would say, so we'd actually print the character out, and that's out string I. Then we print our colon. Then we would print our occurrence. So the occurrence container, not occurrence, I'm sorry, the frequency container. So we do this at, not at I, but at char index. And then we do a new line. So for every one of our characters in the character array, we should be able to print out that frequency, the frequency for that character based on the number of times we've gone through the array. And I'm doing this double, you know, I could have turned this into a function, but it's okay. I mean, this is a, this is just the, you know, we're using a language, a thought exercise, so it's okay if you don't make it as pretty as possible. You just want it to work in the way you expect with no surprises. So let's see, Mary had a little lamb, we go through the thing. All right, so now that we've got the index, what we need to do is, you know, freak occurrence, freak container at character index needs to be plus equal 1. That's the first part. We need to know how many times we've seen each letter. Okay. Okay, so let's see if it works. If it doesn't work, then hey, we gotta debug it, get it to work, and then we'll take a break. All right, so now if we just start debugging, hopefully it doesn't die on us. Continue. Okay. All right, it's looking semi-good. Well, there we go. Now, does this match what we said when we did the walkthrough? So let's go. Oh, actually, you know what I need to do? I need to hide memory, hide all that stuff. Okay, let's go back up and let's look at this. So now 1 3 1 1 3. Ooh, oh, because it did spaces. Yeah. All right, so 2 1 2 1 1 1. Okay, yeah. So then spaces. What happened to you? Why are you there? Oh, and it didn't do B. Great. What didn't I account for? I did not account for. Oh, yeah, right. Well, let me see. So at 19. Oh, I see. I need to stop debugging. I need to, so yeah, that worked, but I'm off by 1 here. All right, I'm off by one here, and I'm off by one here. Okay, and the other thing is I am, what did I do? So ASCII, so between 60, 65 and 90, between 97 and 122, space doesn't belong there, so it shouldn't have been accounted for. Oh, but I wonder, let's see. Let me see if just changing the index actually deals with my issue there. So, well, no, that didn't seem right. But okay, so let's see. So if we do the debugging again, continue, look at what got printed. All right, that looks right, but then the spaces should not be getting accounted for. I wonder, okay, so let me stop debugging here. And one more change that we can make is simply to say that we don't need to print if it's a space. So wait, if I is greater than 65, what is going on here? Outstring I, character frequency container, character index. All right, so I. All right, so let's try this then. If, and I apologize, we got a little bit of bad weather. So let me try and wrap this up and then we'll be good to go. I think all I have to say is if int out string at I is not equal to, well, actually, all I have to do is say if out string at I is not equal to space. I think that's all I have to do. And then I should be able to do the rest of it. So let's see if that's correct. Yeah, I think that might work. So let's try it. If it doesn't work, then either way, we'll take a bit of a break, let the weather calm down, and then we'll try to dive into the second part. Because we still have to say which one showed up the most and then do the occurrence. Let's see, we continue, we look at our printing. Okay, Mary had, oh, and now we're missing an A. Did I not put an A? But okay, so let's see. Did I not? No, I didn't. All right, so it's right and I'm wrong. I didn't put an A to begin with. So we'll wrap up here, and when we do the next video, we're going to continue with this particular problem, and we'll do what we need to do for the letter that showed up the most, and also to print the first occurrence index when the letter showed up more than once. Thanks for watching. I hope you found this useful. If you did, don't forget to hit the like button. If you'd like to continue along with me on this journey, don't forget to subscribe. And if you have anything that you think I should be doing differently, just, leave comments in the comment box below. And thanks again. I'll see you guys again soon. Bye now.